It's easy to get confused with fraction operations. The algorithms are complicated. Do you know when to find the lowest common denominator? When and where should you cancel common factors? Should you convert mixed numbers to improper fractions or vice versa? Help! My basic advice is this. Always come back to the meaning of the fraction. You're dividing up wholes into equal parts. So if you're adding things with the same denominator, that means the parts are all the same size. Just add the numerators. 2/6 plus 3/6 is 5/6. What about related denominators, like 4 and 8? Well, they're not the same size right now, but an eighth is half the size of a quarter, so 1/4 is the same as 2/8. Now I have pieces that are the same size. 2 plus 5 makes 7/8. Sometimes the result is improper. 4/5 plus 3/5 makes 7/5. Don't panic. You can leave it as 7/5, or write it as a mixed number. 1 whole, that's 5/5, plus another 2/5, 1 and 2/5. What about unrelated denominators? 2/3 plus 1/4. Well, I need the pieces to be the same size before I can work this out. What size can I use? I need to break the thirds and the quarters up into pieces the same size. How do I work out what size? Actually, there's another way to draw this. Like when you multiply by drawing an array, here we could draw 3 rows and 4 columns. How many squares have we got in the grid? 12. So we have 2/3, that's 8/12, and 1/4, which is 3/12. Put them together and we have 11/12. Okay, what if they're different but have a common factor? A 1/6 plus a 1/9. Well, the same method will work as before. 6 times 9 is 54. 1/6 is 9/54. 1/9 is 6/54. 9 and 6 make 15/54. But 15 and 54 have a common factor, 3. So this isn't in simplest form. Divide the top and bottom by 3 to get 5/18. See, the thing is, if you can spot that there's a common factor, you can actually do this more easily with smaller numbers. What's the smallest number that both 6 and 9 divide into? What's the lowest common denominator? It's 18. So write 1/6 and 1/9 as 18ths first. 6 times 3 is 18, so 1/6 is 3/18. 9 times 2 is 18, so 1/9 is 2/18. Okay, now we have 3 plus 2 making 5/18. You get the same answer, but we didn't have to use such big numbers, and we didn't have to simplify again afterwards. Both methods work just fine, but personally I'd rather use smaller numbers when I can. And finally, mixed numbers. Well, you have a choice here. You can add the whole parts and then add the fractions. But if the fraction parts add to more than 1, you'll have to adjust the whole number part too. And it can get even more tricky with subtraction. Personally, I recommend changing mixed numbers to improper fractions first. Besides, you'll have to use improper fractions when you get to multiplication and division anyway. Let me show you what I mean. First, let's try just using the mixed numbers. 1 and 3 make 4. Then we have 3/5 and 1/2. Well, what's the lowest common denominator? What's the smallest number that both 5 and 2 divide into? It's 10. 5 goes in twice, so 3/5 is 6/10. 2 goes into 10 5 times, so 1/2 is 5/10. Now 6 plus 5 is 11/10, an improper fraction. This is the same as 1 1/10, so our final answer is 5 1/10. A bit confusing at the end there? Let me show you the other way. Convert to improper fractions first. 1 whole is 5/5 plus another 3 makes 8/5. 3 wholes is 6/2 plus 1 makes 7/2. Okay, now what was the lowest common denominator? The smallest number that both 5 and 2 divide into is 10. 5 times 2 is 10, so 8 times 2 is 16/10. 2 times 5 is 10, so 7 times 5 is 35. Now we have the same denominator, so just add the top. 16 plus 35 is 51. 51/10. Now this is a perfectly valid answer. You can leave it improper if you like. But since the question had mixed numbers, maybe we should give our answer as a mixed number. Well, how many wholes are there in 51/10? How many times does 10 go into 51? 5 times with 1 left over. 5 1/10. See? Same answer as before, but no extra adjustments to the whole number part. Personally, I prefer the second method, but both work just fine. Exactly the same method works for subtraction, except you have to subtract the numerators instead of adding them once you've got the same denominator.